So this video lesson is all about what's known as absolute value. Now to talk about absolute value is going to get us ready for looking at other negative number operations a little bit later this week and next week. And we're going to use absolute value to help inform how those operations work. But before we can get to those, we have to understand what absolute value is, how it's related to directed numbers that we talked about before, and how we can calculate and envision absolute value in several different types of contexts. And so the first thing I want to do is introduce two things that as classes we decided we wanted to look at in terms of negative numbers. The first is going to be temperature, because temperature is an example of a use of positive and negative numbers that really is positive and negative numbers on a number line, because the thermometer, after all, is just a number line that's on its side. Positive numbers are moving upward on thermometers, negative numbers are moving downward on thermometers, and somewhere in the middle there we have a zero. And so part of what we're going to look at with thermometers for this video lesson is the way that we talk about certain numbers when it comes to a thermometer. Sometimes once we get below zero, when it comes to temperatures, we can say, okay, well, it's -2 degrees or something like that. But that -2 degrees is often talked about using the phrase 2 below zero. And if someone says, oh, how cold is it outside? And they say, oh, it's 2 below, that means the temperature is -2. But we don't see the word negative or use the phrase negative in that case. We use the number 2, because the number 2 is a distance of 2 below 0 on a number line. We could, although we don't often say it, use the same thing. We say, oh, it's 2 above, when we say 2 above 0. That's similar to the way that sometimes we say, oh, it's 2:15 or 2:45, 15 minutes on a clock being a quarter of an hour. Talking about the distance that the time is from the regular hour. We also talk about temperatures on thermometers sometimes, about the distance that they are away from 0, especially when we talk about negative numbers. Another context that we're going to use with negative numbers is the idea of distance, and we're going to use elevation, but to talk about absolute value, we're going to talk about distance on a map. And so this map is centered around Cincinnati, Ohio, because it is the center of a lot of different places in sort of the eastern part of the Midwest. And so we can see that there are a lot of other cities around Cincinnati. For example, there's Cleveland, and there's also Chicago. And if we draw the rows and the distances from Cincinnati to Cleveland and also from Cincinnati to Chicago, we see there's a little bit of a difference, but they're essentially the same distance away. And the same is true for something like Toledo and Cincinnati, where the distance from Cincinnati to Cleveland and the distance from Cincinnati to Toledo are about the same, even though they're in different directions. And we can also say the same thing about, and I'll use yellow for this one, Cincinnati to Columbus, Cincinnati to Lexington, and Cincinnati to Louisville. And even though Columbus and Louisville are in different directions away from Cincinnati, we call them the same distance away. And if we tried to give sort of north and south directed numbers, we would say that to go from Cincinnati to Columbus could be a positive movement if we called north positive. And we could say that going from Cincinnati to Louisville could be a negative movement if we wanted to give the direction of south negative, but their distance away from Cincinnati would be the same. And that's because when we talk about distance, we're really just talking about the space between. And numbers on a number line act the exact same way. If we imagine a mirror down through 0, 1 and -1 are the same distance away from 0. 3 and -3 are the same distance away from 0. And that distance away from 0, the space between 0, which we consider often to be the center of number lines when we're talking about positive and negative numbers, is called the absolute value. The absolute value of a number is its distance from 0 on a number line. So go ahead, pause the video, write this down, and come back when you're ready to move on. So when we represent absolute value, we're going to use two vertical lines around a number. So the number 5 has a value of 5. And if we're talking about the distance from 0 on a number line, we're going to use vertical lines around the 5 to represent what is read as the absolute value of 5. The absolute value of 5 as a distance is 5. We can also do that when we say the absolute value of -5, using two vertical lines around the -5. That's read as the absolute value of negative 5, the distance from negative 5 to 0 on a number line. Now, distance, space between things, is positive, so therefore the absolute value of negative 5 is 5. These two numbers have the same absolute value because their distance from 0 is the same. And the last thing we need to do before we get ready to do some practice problems is talk about the many meanings of this sign here. When we first see it in circumstances like 5 minus 2, that sign means subtraction. But that subtraction only makes sense if there's a number before the number being subtracted that we can take it away from. In subtraction terminology, the 5 is called the minuend and the 2 is called the subtrahend. So without a number in front of the subtraction sign, it's not actually a subtraction sign. It only makes sense when there's two values that we're comparing or one that we're taking away from another. Another way that you've seen it is the example of something like negative 5, where that sign means negative. In this case, it only makes sense if there's a number after the sign, and we call that negative 5, because it can't be a negative sign without a number to call negative. On the other hand, what we will see is we might be able to put the negative sign outside of an absolute value, for example, something like that, or a negative sign outside of a parentheses. In both of these cases, this sign means opposite. We read that as the opposite of 3, which just so happens to be negative 3. We read the bottom one in green as the opposite of the absolute value of 5. Well, the absolute value of 5 is 5, and its opposite is negative 5. So when we read it carefully in situations like that, we can start to understand how the many meanings of that dash, being subtraction, opposite, or negative, can impact what we're doing. So here's a few examples of calculating absolute value. You don't need to pause the video. I'll go through these. On the first one in the upper left, that is the absolute value of 1.35. That distance from 0 is 1.35. Moving down to the example here, this is read as the opposite of the absolute value of 12, because the negative sign, the opposite sign, is outside the absolute value. The absolute value of 12 is 12, and we're taking its opposite, so that's negative 12. Up in the upper right-hand corner, we have the absolute value of negative 7/12. Negative 7/12 is a distance of 7/12 away from 0 on a number line, so it's just 7/12. And for number 4, the absolute value of negative 18, that distance on a number line is 18. And so that's how we think about calculating absolute value, and we'll talk more about how it's used in class when you get there. So go ahead, pause the video, write these problems down in your notebook, and then find the absolute value. I'll be looking for both the problem itself and the answer when we check notebooks. Pause the video, work on these, come back when you're ready to see the answers. So number 1 is the absolute value of 215 is a distance of 215 from 0 on a number line. Number 2 is read the opposite, because the negative sign is outside, of the absolute value of 27. The absolute value of 27 is 27. Its opposite is negative 27. Number 3 is the absolute value of 1/2. Negative 1/2, or is a distance of 1/2 away from 0 on a number line. 4 is the absolute value of negative 5.04. That distance from 0 on a number line is 5.04. Number 5 is the absolute value of negative 215. That is a distance of 215 from 0 on a number line, because the difference between 0 and negative 215 is just that distance of 215 units, whatever that happens to be. The absolute value of 77 is 77, because that's the distance from 0. For number 7, the opposite of the absolute value of 8. Absolute value of 8 is 8. Its opposite is negative 8. And finally, the absolute value of 0. How far is 0 from 0 on a number line? Well, it's 0. So as a quick review, absolute value is the distance from a number to 0 on a number line, and we do it by we show it and we calculate it by using vertical lines. So we see vertical lines that are not curved like parentheses, we talk about them as absolute value. They act somewhat like parentheses, but you'll find out in later classes that they are very different. But that is absolute value, and we'll continue going over it in class the next time that I see you.